Hello everyone. In this video I will be explaining my HD task which was about QUIC protocol. So I will be explaining all the working and the architecture, features, what it is, its advantage and disadvantage, and real world implementation. So basically the first thing is like, what is QUIC? So QUIC stands for Quick UDP Internet Connections. It is a modern transport protocol which was been developed by Google. Traditionally, internet communications were being relied on TCP, where the three-way handshake were being used, which works at the transport layer. Whereas the QIC replaces this TCP by combining the transport and the security into a single protocol while running over UDP. So basically this design allows QIC to be the faster, more efficient and more secure, and it is mainly used in HTTP 3, which is the latest version of web protocol used for loading websites. So the thing is why it was been created and why it was been introduced. The main problem is that the connection established delay. TCP requires a three-way handshake. It sends a synchronized request. After that, the server replies with the synchronized acknowledge, and in the last, the client responds with acknowledge. So this is the three-way handshake that was being used by TCP. And when it was been combined with TLS encryption, it requires some additional handshakes. So this increased the latency before the data transmission even begins. So second major issue was in TCP. If one packet has been lost, suppose a packet has been lost in TCP, all other packets must wait until it has been retransmitted. So this delays the entire communication. The third thing is the poor performance in the mobile networks. Like suppose when you are switching networks like Wi-Fi to a mobile data, the TCP connection often break and must restart there. So all these three problems, to overcome these, the solution is QIC. QIC solves the solutions by reducing the handshake time, by allowing independent data streams, and supporting seamless connection migration. So now the main thing is how it works. It basically works or operates over UDP. It behaves like a full transport protocol. So the first step, it is the initial connection, that is the handshake. So when a client connects to a server, the QIC uses a cryptographic handshake. It basically combines the transport plus encryption setup in one step. So what it does, that it reduces the delay as compared to the TCP plus TLS that was being used in there in three-way handshake. The second step is the 0 RTT and the 1 RTT connection. What it is that 1 RTT is the first time connection and 0 RTT is the repeat connection. In 1 RTT, one round trip is being needed, and in the 0 RTT, data can be sent immediately. So this basically reduces the loading time. After that, the third step is packet transmission. In packet transmission, each packet contains an header which includes connection ID, packet number, and an encrypted payload. So unlike TCP, everything has been encrypted here. Step 4 is the multiplexed streams. QIC basically divides the data into multiple streams. For example, video is in the stream 1, audio is in the stream 2, subtitles are in the stream 3. So if one stream has been delayed, other continue normally. Whereas in the TCP, it has to wait until until the first stream has been retransmitted. So this is the major thing that comes here. Step 5 is the loss detection and the recovery, whereas the QIC detects the packet loss using the packet numbers and acknowledgement. So it retransmits only the lost data, not everything. Last step is the connection migration. Like suppose if a user switches the network, like it has been using a connection ID, so connection continues without restarting. So whereas in the TCP there's a delay in between that. So now coming to the key features of it. So the key feature is the 0 RTT, that the zero round trip time. So in old protocol, old protocol like TCP, you have to wait before sending the data, whereas in QIC, if the server is known, data has been sent instantly. So this improves the speed for repeated visits. Second is the multiplexing without any blocking. So in TCP, one packet loss stops everything, whereas in QIC, streams are being independent, and so this removes the head of the line blocking completely. Third is the built-in encryption. QIC includes encryption by default. It uses the TLS 1.3 and all packets are being encrypted. So this improves the security and privacy. Fourth is the connection migration. where the QoC allows switching from Wi-Fi to the mobile data without any disconnecting or any delay. So it is important, or it is very useful for the mobile users. Now comes to the, this is the thing, that this is the basically diagram which shows the old TCP handshake and the new QoC handshake. So here you can see that the three-way handshake has been done, and here it has been reduced, so the time delay has been reduced, and it is QoC is more efficient. Basically QoC is being used in Google Chrome, YouTube, mainly in YouTube. You can see HTTP 3 has been used. Now HTTP 2 is not much used. So coming to the advantage is like it has been faster page loading, it reduces the latency, it is better streaming experience, it improved performance in unstable networks, it has a strong security and privacy. So this makes QoC ideal for the modern application. Some disadvantage it also has, like it has limited browser support. Not all the browsers or the servers fully supported QoC. There are many debugging challenges. It is hard to debug due to the encryption, and it requires more processing power, and it is not fully supported by the older system that is being supported by TCP now also. And as I already said, that it is widely used in YouTube, Google Chrome you can see, or you can see it in the HTTP 3 websites also. All the many modern platforms, they are being shifting to QoC for the more better quality features, basically you can see. So these are some real world application, the HTTP 3 and the Google services I have already, and the YouTube is also one of it. These are some, what are some like security and the threats. So QoC provides strong security because all communication is encrypted. It prevents the eavesdropping also, but it has some threats also. For example, like it is harder for the firewalls to inspect the traffic. It can attack the detection, which can become complex afterwards, and it can use some traffic analysis. It is more advanced monitoring tools. So these are some security, privacy, and some threats that QoC could have. So now I will show a Wireshark demo explanation. So before I am demonstrating the QoC traffic using the Wireshark, first of all I will open my Wireshark. Yeah. Wait a second. Yeah. Now here I will choose Wi-Fi because I have a wireless connection. Yes. So you can see basically all the types of protocol will be there, and it has been running. So I have to only choose QoC. So I will go to my Chrome. So here the YouTube video has been going on. Suppose I will click on it, or suppose the YouTube video has come here, or you have been watching a YouTube video. So you will go back to your Wireshark here. So you will stop the recording first by clicking on the red icon. So after that, yeah, as you can see I have so here what I will do, yeah, to basically generate the QoC traffic, I will open I have already opened Google Chrome and I have accessed the YouTube, because YouTube uses HTTP 3 and QoC protocol. So I have already played a video for a few seconds or few minutes, which will generate some sufficient network traffic for it. Suppose if I have around 4 minutes it has been watching. Yeah, now I will go to my Wireshark. So here I will identify the QoC packets. To identify it, in the filter section I will write QoC. Yeah, so here all the QoC protocol will be there. If QoC packets are not, if suppose the QoC packets are not directly visible, you can also use the filter, that is the UDP.port equals to 443. So after you can see here that the filter results are being the QoC protocols, and these packets have been transmitted over the UDP, which confirms that QoC uses UDP instead of TCP. So now I will click on any one of the packet to show its detail. Suppose this one only, this is I will show. So in this you can, unlike in the traditional protocol, QoC encrypts most of its data, which is why we cannot see readable content in the payload. So basically what it does, it improves the security but makes the packet inspection more complex. So here you can, in this here you can see, observe that some important fields like the packet length, You can see the connection, source connection ID, destination connection ID, the packet number, the encrypted payload. So these are some important things, fields you can observe. And so basically this demonstrates that the QIC combines the transport and encryption and operate efficiency over the UDP. Here I also share a unique thing. So here you can see there are different types of filter, like different type of packet types, like initial packet types, protected is there, handshake is there, or a short header packets are also there. So basically these are the different stages of QIC communication. I will give a small description of all the three. In the initial packets, which is quite important, this is the start of the connection. It is used when client connects to the server for the first time. Basically it contains the connection ID and the initial handshake data. It is like you are being saying something like, I want to connect to you, hello, I want to connect to you, something like that. The second thing is the handshake protocol. Yeah, so basically what is that? This is a security setup phase. Encryption keys are being exchanged here and secure connection has been established. Now the third thing is the protected payload. Yeah, the protected payload is like, you can see it is a actual data transfer phase. Real data has been sent here, all the video and the website content has been sent, and it is fully encrypted. So all the actual communication is been happening here. So basically overall, initial packet basically explain the connection start, handshake packet explain the security, and the protected payload explain the data transfer. So this is the basically overall my, I would say, the Wireshark demo. So in conclusion, I could say that QIC is a modern, efficient and a secure protocol which improves the internet performance and solves major limitations of TCP and plays a key role in HTTP3 and future network technologies. Thank you.